inequalities. I really want to stress here that if you aren't comfortable with any of the other, if you're not feeling like you've really mastered rational functions, work on that. Do some extra practice with those before you tackle this. If you're feeling like you need something more, this is your something more. So we're just introducing inequalities here instead of just equations. And we're going to be looking a lot at zero. Zero is a really helpful reference. So for this first function, we're given the graph. For the whole front, we're just looking at graphs. So we're given the graph, and we're going to evaluate where we are less than zero to start. So I'm going to color code a little bit. It looks like we have a horizontal asymptote at y equals 0. It's a horizontal asymptote that we do cross. It looks like here in the middle. And we have this horizontal asymptote at y equals 0. We have two vertical asymptotes. And those are really the places that we're looking. Asymptotes and zeros are where our function is going to be switching from negative to positive or positive to negative. So where are we less than 0? Okay, so this whole branch down here is going to be less than 0. So that's from 1 to positive infinity. And this middle piece is less than 0. Here it's just less than, so we're not going to include 0, but we are going to go here to negative 1. So that would be negative 1 to 0. All the way over here to the left, that guy's above the x-axis, and we know that that's going to stay above the x-axis. We know that's not going to cross as we go to infinity. Our function wants to approach 0, but it's never going to get there. So I'm going to do this in interval notation and set notation. I think it's really helpful to kind of have these things written on our graph already. So in interval notation, we're going to go from negative 1 to 0. At the asymptote and at our x-intercept there, we are not going to include those because of that open circle, because this is just a less than, and because it's an asymptote. So negative 1 to 0. And we're going to join that with the little u. We're also going to go from 1 to positive infinity. That's where our function is less than 0. The way this looks in set notation, x such that x is, between negative 1 and 0. Or x is greater than 1. So there's your set notation. If you are thinking of tackling this extension on the unit test, you will be asked to do both interval notation and set notation. But that will be the same on the test for the other problems as well. All right, let's look at where f of x is greater than or equal to 0. So now we're looking above the x-axis. Again, we're looking asymptotes and zeros. So here, going left to right, we're above the x-axis here. So I'm looking negative 3 to negative 1 now. And then we're also above the x-axis, starting at x equals 0 to x equals 1. So from 0 to 1. And this time we're going to include 0 because of this equal to over here. So in interval notation, we're going from negative 3 to negative, that should be negative infinity. What am I thinking? Negative infinity to negative 1. And then between 0 and 1, and we're going to include 0 because it is a point on our graph. We're not going to include 1 because of the asymptote. The way that looks in set notation, x such that x is less than negative 1. Or x is between 0 and 1, and then we're going to be really careful here. We're going to do equal to with a 0, and just less than with a 1. So a lot of detail work here. Should have been an infinity there. Sorry about that. Hopefully you thought I was going crazy there for a minute because you were paying really close attention. All right, let's look at number 2. Again, graphing rational inequalities. Again, we're looking at where we're less than 0 and greater than 0. greater than or equal to. Color coding, I think, really helps. So for part A, where our function is less than 0, we're looking below the x-axis. So where is our function below the x-axis? And we're not going to include any points that are on the x-axis. So we're thinking kind of open circle here. So where are we below the x-axis? Well, from 1 to 2, and from 2 to 3. But we're not going to include 2 or 1 and 3 because of this less than. So in interval notation, again, we said from 1 to 2 and from 2 to 3. Notation. We're going to do x's between here. It's easier for me to do it as a fill in the blank. So x is greater than 1 and less than 2. X is greater than 2 or less than 3. So that is set notation and interval notation for f of x is less than 0. All right, I'm going to clean up my graph a little bit so we can do greater than or equal to. So I feel like the hardest part with this is really being careful with those symbols, your less than or equal to's, your parentheses, and your brackets. So for f of x is greater than or equal to 0, now I'm going to look, where are we above the x-axis or on the x-axis? So this whole branch there, that's going to be negative infinity to negative 1. That's all above the x-axis. Then from negative 1 to our 0 here at 1, we have another piece that's above the x-axis. And from 3 to infinity, we're above the x-axis. So I just need to make sure all of those kind of dark pink areas that I traced over, we need to get those in our interval notation. So from negative infinity to negative 1, I'm not going to include either of those. I'm going to use parentheses there. From negative 1 to 1, I'm going to bracket 1 because it is a point on my graph because of the equal to. And I'm going to bracket 3 because of the equal to. Awesome. Now let's do set notation. So x is less than negative 1. We're between negative 1 and 1. Greater than 1, less than or equal to, I'm sorry, greater than negative 1, less than or equal to 1. We need to have ors in here. And then x is greater than or equal to 3. If there's one notation that you're more comfortable with than the other, that's absolutely fine. I think you can probably tell from the order that I do things. I'm more comfortable with interval notation, and that actually helps me to do interval notation in order to get the set notation done. All right, number 3. Number 3 says solve r of x is less than 0, where r of x is equal to x over x minus 1 times x plus 2. So we're kind of ramping up to doing this algebraically. What we're looking at here is just putting the graph in your calculator and kind of seeing what you got. Here we know we have vertical asymptotes at x equals 1 and x equals negative 2 there from our denominator. And we know we have a root in x-intercept 0. And so those are the places, as we work toward doing this algebraically, those are the places where our function could switch from negative to positive. And so those are the places we're going to focus in when we're solving an inequality. Here, if I break up each of those sections, kind of just look at each separately. This first one, x, as we're looking at -2, here we're doing where we're less than 0. So this whole branch is less than 0. So if I'm going to go ahead and start building my interval notation from -infinity to -2, we're definitely below 0, below the x-axis. It's just strictly equal to, so in this middle, now we're looking between 0 and 1. We're not going to include 0, but from 0 to 1, we are below the x-axis as well. After we get past that asymptoted x equals 1, we're above the x-axis. So this is our solution. In set notation, let's see, x is less than -2, and x is between 0 and 1. Just double checking my symbols there. All right, let's look at one more strictly graphically before we introduce any algebra in. This guy, 2x plus 4 over x minus 1, go ahead and graph this on your own, and I'll tell you what key points I got here in just a second. So if you would pause and get that graph in your calculator and get some key points on your graph. So what I have on my paper is an asymptote at x equals 1. Of course, from that x minus 1 in the denominator. I have a horizontal asymptote at 2, y equals 2, since our leading coefficients are 2 over 1 and they have the same degree. And then the key points that I graphed were at, let's see, 2, 8, and 4, 4. And of course we had a x-intercept, let's see, 2x equals -4. Our x-intercept is -2. And then our y-intercept is -1. That's a really pretty graph. I like that one. So where is our graph greater than or equal to 0? Well, again, where we're switching are zeros and asymptotes. So here's the 0, and we're doing greater than or equal to. So here's the 0, and we're doing greater than. So we're greater than here. And we have an asymptote at 1, and up here, on this second little curve, we're above the x-axis. So I'm seeing -infinity to -2, and 1 to infinity. I'm going to include -2 because it's a root. I'm not going to include 1 because of the asymptote. And then quit notation. See, x is less than or equal to -2. X is greater than 1. The only thing we're going to add in on the back is just the algebra that goes with this. So setting our function equal to 0, getting everything on the same side, and kind of looking at intervals and graphing these a little more. So if this is enough, if you're really comfortable with the algebra that we did last unit, you might be able to, you might not need to look at that next set of notes, you might be able to fly. If you want to watch them, there's going to be a second video that shows you the algebra